Welcome back to The Explainer. I was thinking recently, what actually happens when abstract, hyper-advanced software crashes headfirst into physical, real-world reality? Well, we don't have to wonder anymore, because that is exactly what happened in April 2026. If you follow this space at all, you already know it was an absolutely chaotic month. We saw massive data dumps, wild model releases, and financial moves so big they almost don't feel real. But when you step back and look at the whole picture, April 2026 wasn't just busy. It was, without a doubt, the most consequential month in the entire history of artificial intelligence. Today, we're going to break down exactly what went down, and more importantly, why it matters for all of us. To really set the stakes here, I want to bring up how the Cursai report summarized the month. They said, this is no longer a technology story. It is an economic, geopolitical, and societal inflection point. And honestly, they hit the nail on the head. The sheer scale of the shift we witnessed in just 4 short weeks is almost hard to overstate. We aren't just talking about chatbots getting a little bit better at writing your emails. We're talking about miles suddenly hitting human expert levels across dozens of professions. We're talking corporate mergers valued in the trillions, and entire global industries just totally restructuring their workforces around autonomous agents. And the financial reality of this technological leap? It is staggering. $297 billion. That is the global startup investment total for just the first quarter of 2026 alone. That's a 150% increase both quarter over quarter and year over year. The money flowing into this space right now is literally unprecedented in the history of modern venture capital. What it tells us is that the world's most sophisticated investors have looked at the tech and collectively decided the future is arriving much, much faster than anyone thought. So, here's our roadmap for today. First, we'll look at the April 2026 inflection point. Second, the frontier model wars. Third, the model locked away. Fourth, capital and the agentic shift. And finally, number 5, the physical AI reality. All right, let's dive into part 1, the April 2026 inflection point. Before we get super deep into the weeds with neural networks and parameter counts, we really need to grasp the sheer density of events that happened basically all at once. According to data from the Stanford HAI 2026 AI Index and Cursai's reporting, April was defined by this unprecedented convergence. In a single month, we saw 3 massive frontier models, the absolute cutting edge of capability, launched or confirmed by OpenAI, Anthropic, and Google DeepMind. At the same time, Elon Musk's SpaceX acquired xAI, creating this vertically integrated behemoth valued at $1.25 trillion. Plus, the Stanford report dropped the bombshell that organizational AI adoption has hit 88% globally. And what's powering all of this? A 30-fold increase in global AI compute capacity since 2021. None of this happened in a vacuum. Every single one of these developments feeds into and supercharges the others. Okay, moving on to Section 2, the Frontier Model Wars. These top-tier model releases just completely reset the baseline for what AI can do. Let's start with OpenAI's GPT 5.4. It managed to score an 83% on a benchmark called GDPval. And why does that matter? Because GDPval rigorously tests real-world knowledge work across 44 different human occupations. We're talking lawyers, software engineers, financial analysts. Hitting 83% means the model matched or beat human industry professionals in 83% of those direct comparisons. Incredible, right? But then, Google's Gemini 3.1 Pro took a totally different route. It scored a staggering 94.3% on the GPQA Diamond benchmark. That benchmark measures brutal, graduate-level science questions, and 94.3% is the highest score ever reported there. You can really start to see the distinct architectural bets these tech giants are placing. OpenAI basically built GPT 5.4 to be the ultimate unified generalist. In the past, you'd need specialized variants of a model for different tasks. Well, not anymore. GPT 5.4 simultaneously leads the pack in coding, computer use, reasoning, and broad knowledge work, all in one. Google, on the other hand, pushed Gemini 3.1 Pro toward incredible depth. It's natively multimodal, processing text, audio, and video completely seamlessly, and it leverages a massive 1 million token context window. That means it can hold entire books of information in its immediate memory, allowing it to just dominate in novel, abstract reasoning and deep scientific problem solving. It's 2 very different but equally amazing approaches to pushing the boundaries of intelligence. Which brings us to Section 3, the model locked away. Now this is where things get a bit chilling. What happens when the pursuit of intelligence goes a little too far too fast? It's a question the industry has kind of quietly dodged for years. What actually happens when a model is just too smart to release? Well, in early April, Anthropic confirmed the existence of Claude Mythos 5, the industry's very first 10 trillion parameter model. Just think about that for a second. That is an artificial brain of unimaginable scale. It's equipped with dedicated expert clusters for insanely complex tasks like software engineering and full attack chain cybersecurity analysis. But there was a major catch. Anthropic announced they wouldn't be releasing it to the public. It turns out, during their internal testing, Claude Mythos 5 triggered Anthropic's ASL4 safety protocol. This is a classification they reserve specifically for models that are approaching genuinely dangerous capability thresholds. So they built it, they tested it, and they officially deemed it too capable to safely deploy. This is a huge deal. It establishes a profound historical precedent. It means that capability gating at the lab level isn't just some academic theory or a PR talking point anymore, it's operational reality. Just because a model is successfully trained no longer guarantees that you or I will ever get our hands on it. Let's shift gears to Section 4, Capital and the Agentic Shift. As these models get vastly more complex and certain capabilities get gated, the underlying economics of the whole tech industry are violently shifting. Get this, a massive 81% of all global startup funding in the first quarter of 2026 went directly to AI startups. That left just 19% for literally every other sector combined. Think about that. Capital is fleeing traditional software, biotech, fintech, you name it, to concentrate almost exclusively on AI models and infrastructure. And that mountain of capital? It is incredibly concentrated right at the very top. In Q1 alone, OpenAI raised $122 billion. Anthropic took in $30 billion. xAI raised $20 billion, and Waymo raised $16 billion. Just those four megadeals combined total $188 billion. To put that into perspective, those four rounds exceeded the total global venture funding of all of 2024 combined. No joke. We are witnessing a concentration of financial power that is fundamentally rewriting the global business landscape. But what are businesses actually doing with all this tech? Well, the answer is right here in this number, 79%. Recent research shows that 79% of organizations have now adopted some level of agentic AI. This is a massive paradigm shift. We aren't just prompting chatbots to write essays anymore. Agentic AI means systems that autonomously plan, act, and learn to achieve goals without needing a human to hold their hand step by step. Whether it's coding, customer support, or legal analysis, the most successful businesses in 2026 are increasingly structured around leading teams of AI agents rather than just managing teams of people. And that leads us to our final section, number 5, the physical AI reality. Because here's the thing, all this software, all these autonomous agents, and these 10 trillion parameter models, they have to live somewhere, right? Bringing this whole narrative out of the cloud and into the real world, the Stanford HAI data outlines a compounding exponential growth curve that is frankly hard to wrap your head around. Since 2022, the world's AI compute capacity has grown by roughly 3.3 times every single year. So by the time we hit 2026, we're looking at a 30-fold total capacity increase compared to 2021. You simply cannot scale physical digital infrastructure that aggressively without eventually slamming into the hard limits of physics and engineering. Which brings us to the immense infrastructure strain we're seeing right now. The US is currently facing a projected 9 to 18 gigawatt power shortfall by 2027, and that is driven almost entirely by the race to build out AI data centers. The power grid just simply cannot keep up. Because of this, major tech giants and hyperscalers are taking matters into their own hands. Microsoft is literally reopening the 3 Mile Island nuclear plant, Amazon is pursuing dedicated nuclear sites, and alongside this massive power draw, carbon emissions are soaring. For instance, the training run for Grok 4 alone was estimated to produce 72,000 tons of CO2 equivalents. The digital realm is placing a massive, tangible tax on the physical world's resources. And speaking of the physical world, AI is quite literally walking around in it now. The robotics wave has officially arrived. Over at the Hong Kong InnoX Fair in April, we saw humanoid robots doing everything from boxing matches to executing complex rescue operations. Commercial-grade humanoid robots are actively shipping to warehouses and manufacturing floors today. And it's worth pointing out that while the US currently dominates the software and model side of the AI race, the physical AI robotics wave is rapidly accelerating on a global scale. China, for instance, is heavily leading industrial robot deployment right now, with 295,000 recent installations. So the real crucial takeaway from this explainer is this. We are witnessing a profound collision, On one side, we have practically limitless software potential. Agentic workflows are multiplying, model capabilities are compounding, AI systems are drafting their own peer-reviewed papers. But on the exact opposite side, we are slamming into very real, very stubborn physical bottlenecks. We've got severe electrical grid constraints, massive dependencies on just a handful of chip fabrication plants, and gigawatt-scale energy shortages. The limitless digital revolution has officially collided with our finite physical world. Which leaves us with the ultimate question coming out of April 2026. The models have arrived, the capital has been deployed, the intelligence is absolutely here. But as we stare down the barrel of massive energy shortfalls, and as we see models locked away in labs because they are just too capable to safely release, do we actually have the power and the guardrails to run it? It's the challenge that is going to define the rest of this decade. Thank you so much for joining me on this explainer. Keep learning, stay curious, and I'll catch you next time.